Hello. Uh, Today we're working with logarithms still, and our big goal is to be able to evaluate them by hand. So some of that's going to be using rearranging, and some of that's just going to be deducing um, how to arrive at the value of a logarithm by thinking about how exponents work and doing a little bit of rearranging. The other thing that we'll talk about a little bit is how to use a calculator. Or web application to evaluate a logarithm. These are mostly going to be whole number logarithms, or maybe a fraction or a negative number or something like that. We're not going to get long. Our goal is to not end up with long decimal chains. Um, Eventually, we'll be using calculators to do kind of those decimals. Uh, we are not going to talk about the change of base formula until after spring break. So that's a method to change the base. So before we get into all of that, talking about evaluating logarithms. Evaluating logarithms, and um, some of this is just going to be review of what we did last time for rearranging them. So if you don't remember, logarithm with some base of some number, say, is equal to some other number. Okay. Today we're mostly going to be given this information. A and B will be two numbers, and we'll need to find C. Okay. And a logarithm is just an exponent. So this is the exponent. This is the base. And then this is the value. And remember, this is not an exponent. Like it's not x to some number, but it is the exponent because what we're saying is we can rearrange this logarithm so that the base to the exponent equals this value. So b to the c, whatever that is equal to a. So we can rearrange the log into an exponential statement. And we're going to use this to deduce what c might be today. Eventually, we'll talk about a formula to change this to be 10 because our calculators, most of them can do this base, whatever number we want here. And I showed you how to do that on Desmos. We'll look at it again. But the log button, like if you have a calculator or using your phone, assumes that this is 10. So if you have like log of 5, I don't know what that is, but this assumes that it's log base 10 of 5. And if we just type into Google log 5, nothing comes up because we need the calculator. Log 5. Is like 0.69 something, 89. I like using 4 decimals. That doesn't really matter, but the key here is that if you just write log of something, the base is actually 10. So 10 to the 0.69 is equal to 5. That's what it's saying. This goes on forever. This is probably irrational. This probably goes on forever. Okay. So we rearranged these last week. We rearranged the logarithms into exponents, and we rearranged the exponents into logarithms because you can go both ways. Today we want to say, okay, if we know these two numbers, what's this number? And we're going to use deduction to do that. Maybe sometimes the calculator. All right. So, for example, evaluate the logarithm. The first one is going to be log base 4 of 64. Now, none of these I'm going to know off the top of my head, especially, yeah, I'm not going to know these, right? And I don't expect you to know them either. What I expect you to do is, okay, this is equal to some number. We don't know what it is yet. And we can rearrange this log and the exponent to be 4 to the number is 64. So what power, 4 to what number, what does this number need to be to make this 64? Well, 4 by itself would just be 1. If I multiply this, that's a 16. That would be 4 squared. 4 is just 4. If we multiply by another 4, 16 times 4 is 64. That's 3 4s. So this number, log base 4 of 64, has to be 3. Has to be 3. So this would be my answer. 4 to what exponent? What's the exponent? That's what this is saying. 4 to the exponent of 3 gives us 64. Now this is the kind of thing you might need to multiply out or use a calculator for. I just did 16 times 4 in my head really quick. 4 times 1 is 24. Excuse me. Gives me 64. Okay. Base 5 of 0.2. I'm going to... no. We don't know yet. We don't know what that is. That's going to be some number. So 5 to the number is 0.2. Now 0.2 is a fraction. 0.2 is a fraction. So we can think of this as 0.2 is 2 over 10, 1 over 5. 1 over 5, which means what does this power need to be? Well, it needs to be negative, because that will make a fraction. And it needs to be 1. Because 5 to the negative 1 is 1 over 5. We flip this into a fraction when we have negative exponents. So a log can be a negative number. Log base 5 of 0.2 is negative 1. This would be our answer. So I'm just rearranging and then using deduction or thinking about what it means to be an exponent to figure out the value of the log. Log with a base of 1 over 5. What is that? With 125 as the value? Well, what does that equal? So we want whatever number this is. We're saying 1/5 to some number gives us 125. So what this is saying is we're going to multiply this fraction over and over and over a certain amount of times, and that gives us a big number. Well, remember, this negative turned this integer into a fraction, right? Negative, we flipped this over, which means this has to be negative because that's going to flip this over. So that number is going to be negative, not 1, sorry. It's just going to be negative. Negative. And how many times do we need to multiply 5 to get 125? Well, 5 by itself is just 5. 5 times 5 is 25. 5 times another pair of 5s. 25 times 5 is 125. So it's going to take 3, but we need this number to be negative so that this 1/5 flips over to be 5. And so our number is -3. And so we get log of 1/5, base of 1/5 of 125 is -3. So that's our answer. Okay, a lot of these are not going to be like immediately apparent. Evaluating these logs is going to be like, oh, that's 3, or oh, that's 7, or oh, that's 2, or oh, that's -4. No, you're going to have to think about how do exponents work, multiplying over and over and over. How do negative exponents work sometimes? And we're going to deduce the answer. There is a way to do this with the calculator only, but we're going to wait to talk about that till after spring break. I want the key here to be, can I rearrange the logarithm so that it's an exponent? We don't know the number in the exponent, and that's the number we're trying to think of. This would be C. Sorry, one more. So if I have log base 36 of 6 equals, we want to know what this is. What does this equal? Now, if you plug this into your calculator, just do log of 6, that's not going to give you what we're looking for. Log of 6 is, don't actually know, 0.7781, and it goes on forever. So this logarithm means that the base, an exponent with the base of 36 raised to some number, is equal to 6. This number is smaller. 6 is smaller than 36, right? So our exponent here is not going to be 2 or 4, because that would make this number bigger. It needs to be smaller. You can also think, okay, 36 is 6 squared. To get from 6 squared to 6, we need half of this. We don't need half of 36. That's just 18. We need half of the multiplication for 6 squared. We just need half of this multiplication. So what we're saying is the square root of 36 is 6. And our exponent, if you remember back like 2 units to before winter break, we said the square root is a half. Okay, so the number we're looking for is a half. Log base 36 of 6 is 1/2. Okay, so the key to these, when it says evaluate this logarithm, or what's the evaluation of this expression, is to rewrite the logarithm so that it's an exponent, and then think about what this exponent needs to be. To make this a true statement, 36 equaling 6, this exponent needs to be something specific. Okay, so let's do no, I think that's it. Now remember, your output here could be negative, it could be a whole number, it could be a fraction, it could be anything, because if you remember the shape of a logarithm, when I graph log of something, the curve looks like this. We can only put in positive numbers. We can't put in negatives. So if you put log of like -10 into your calculator, you're going to get an error. If you do log of -10 or any negative number, you're going to get an error. And same thing if you do log of 0. You might get something else that's a bit weird. Like Google says this is -infinity, which is kind of true. You might also get an error, depending on your calculator, kind of calculator you have. Log of 0. This is saying, okay, what value, right, this is 10. So 10 to what number gives me 0? Well, there's not a number that puts out 0, right? Because if we put 0 in the exponent, we get 1. And if we do positive numbers, we get things bigger than 10. If we do negative numbers, we get fractions. We get things smaller than 0 or smaller than 1. But we don't get negatives. It's not going to make a negative number. So that's what this is saying, is that, sorry. This really shouldn't be negative infinity. I don't know why Google says that. It approaches negative infinity. It probably is negative infinity. Whatever. You're going to get errors. Okay? Because this line is never going to cross the y-axis. So we're saying we can get any number out. The y values are the domain, or the range, sorry. The range is all reals. The domain is numbers greater than 0. So we can only put numbers in here that are bigger than 0 into the log. But what we get out could be anything. Could be anything. Okay? So you might get negative exponents, you might get 0, you might get positive exponents, you might get fractions. Or decimals. I think it's easier to think about the fractions though. Okay? So we're just rearranging the logarithms. And then calculating or thinking about what exponent value do I need to make that logarithm true. What's the exponent? So we're finding exponents here. That's what logarithms do. They tell you what the exponent is. All right? So you're going to do some practice with this, and maybe you have time to work on your homework. But that's it this week. Today. Not this week. That's it today. Okay? So we're evaluating a logarithm. You're given a logarithm statement. You need to rearrange it, figure out what the exponent is, and then you're done. Okay?